In this lesson, let's look at how to solve rational inequalities. This process is very much like the process that we used to solve polynomial inequalities in the last lesson. You've got to start with 0 on the right side of your inequality and all one fraction on the left side. And our critical numbers are now going to be the solutions of the top set equal to 0 and the bottom set equal to 0. Critical numbers that come from the denominator cause the expression to be undefined. Therefore, we will never use brackets with bottom critical numbers. The bottom critical numbers never use brackets, always parentheses. And we'll see that as we go along. So here's our first example. X minus 4 over x plus 3 is greater than 0. So notice that we already have 0 on the right side and all one fraction on the left side. So that's one thing we need to get started. Now the critical numbers are going to be the solutions of the top set equal to 0. So the top critical number is 4. And then the bottom critical number, we set the bottom equal to 0, and that's negative 3. So just like we did in the last lesson, we're going to lay out our number line with negative 3 and positive 4. And we're going to make the same table we made before, where we choose a representative from the left, from the middle, and from the right. And we're going to test them in our inequality. So I'm going to choose negative 10 to represent the left side of my line. And let's choose 0 for the middle and positive 10 for the right. And what we're doing as we go along is we're plugging each of these numbers into the inequality expression, and all we're really interested in is the sign of the answer. So if I plug negative 10 into our fraction, negative 10 minus 4 makes a negative number for the top. Negative 10 plus 3 makes a negative number for the bottom. So negative over negative is positive. And then, is that greater than 0? Yes. Okay, let's do the same thing with 0. 0 minus 4 is negative, so that's the top. 0 plus 3 is positive. Negative divided by positive makes a negative answer. Is that greater than 0? No. Okay, for the last one, 10 minus 4 is positive. 10 plus 3 is also positive, so we get positive over positive, that's positive. Is it greater than 0? Yes. So we see that the two segments that give us a true statement, a true inequality, are the left end and the right end. So let's shade those two. And now let's decide if we want brackets or parentheses. And of course, without the or equal to line, we'll want parentheses. And then we'll write the interval notation for each piece. So this is going to be negative infinity to negative 3, and then 4 to infinity. And that's all there is to that one. Now here's a second inequality, and this one again we've got all one fraction on the left and we've got 0 on the right, so this one should not be very difficult either. And we'll start by finding the critical numbers. So the top critical number is where we set the top equal to 0. We'll have negative x plus 2 equals 0. Notice that since x is negative, the easiest thing to do is to add x to both sides. And if we do that, we get x equals 2. For the bottom critical number, we have x minus 4 equals 0, which means x equals 4. And our two critical numbers then are 2 and 4, and we'll just have to set up our little table and choose a number from each section to test. So I've got left, middle, and right. And now something from the left end of the number line, something less than 2, I guess we could use 0. And then for something in between 2 and 4, let's use 3. And for something on the right end, let's use 10. Could use anything as long as it's bigger than 4. Okay, now plugging in 0 into our inequality, 0 plus 2 gives us a positive for the top, and 0 minus 4 gives us a negative for the bottom. Positive divided by negative is negative, and is that going to be greater than 0? The answer is no. Now let's plug in 3. Negative 3 plus 2 makes negative 1 for the top. 3 minus 4 makes negative 1 for the bottom. A negative divided by a negative makes a positive answer. And is that going to be greater than or equal to 0? Yes. And let's plug in 10. Negative 10 plus 2 makes negative 8 for the top, so that's negative. 10 minus 4 makes positive 6 for the bottom, so that's positive. Then negative divided by positive is negative. And is that going to be greater than 0? The answer is no. So the only yes this time is in the middle. We'll graph the middle of our number line. And this time, notice that we have or equal to, so we should use brackets. But remember, we're not allowed to use a bracket for the bottom critical number, so we'll have to use parentheses. Now I want you to take a look at the reason why. If you can imagine plugging 4 into this expression, negative 4 plus 2 would give you negative 2 in the top, and 4 minus 4 would give you 0 in the bottom. So if you have negative 2 over 0, then the expression is not equal to 0, it's undefined. That's why bottom critical numbers can never have a bracket, because they make the expression undefined. So I gave the bottom critical number a parentheses, and our interval notation is 2 to 4, bracket 2, comma 4, and that's really what you're after with the answer, is just the interval notation. And here's another one, and this time we start off with something that's not 0 over here. So let's look at x plus 1 over x plus 3 is greater than or equal to 2. Well, of course, remember we have to start with 0 on the right side. So if we subtract 2 from both sides, we do have 0 over here now, but now the problem is that this is not all one fraction. We'll have to get a common denominator for this whole number and this fraction, and we'll have to combine this all into one fraction. So if I need this expression and the 2 to both have the same denominator, they could both have x plus 3 as a denominator. Alright, now if I distribute that negative 2 times x is negative 2x, negative 2 times 3 is negative 6. And so now this is all of the top, and the bottom is x plus 3. And if we combine the like terms in the top, x minus 2x is negative 1x, 1 minus 6 is negative 5, and now we'll have to find the solutions of the top and the solutions of the bottom. If we take negative x minus 5 in the top equals 0, then negative 5 equals x. And if we do the same for the bottom, if x plus 3 equals 0, then x is negative 3. So our two critical numbers are negative 5 and negative 3. We'll set up our table. We'll choose something in each section to graph. Something that's less than negative 5 would be negative 10. Something in between negative 5 and negative 3 would be negative 4. Something that's to the right of negative 3 might be 0. So let's use negative 10 here, plug in negative 10. Negative 10 minus 5 makes 10 minus 5, which is positive. Plugging negative 10 into the bottom, negative 10 plus 3 is negative 7. So a positive over a negative makes a negative answer. Is that greater than or equal to 0? No. Let's plug in negative 4. Negative, negative 4 minus 5 makes 4 minus 5, which is negative. On the bottom, negative 4 plus 3 makes negative 1, which is negative. Negative divided by negative makes positive. Is that greater than or equal to 0? Yes. Okay, plugging in 0. 0 minus 5 is negative. 0 plus 3 is positive. Negative divided by positive is negative. Is that greater than or equal to 0? No. So the only part of the graph that we shade here is the middle. And now we have to decide whether to use brackets or parentheses. So our symbol says to use a bracket, but we know that only the top critical number can use a bracket because the bottom critical number makes the expression undefined. So the bottom critical number has to get a parentheses. And then our interval notation is simply negative 5 to negative 3. Okay, one last one for us to do together. Let's look at 2x over x plus 1 is less than or equal to 1. So the first thing to do is make it say 0 on the right side. So we'll have to subtract 1 from each side. The next thing to do is to get common denominators because we need to combine this all into one fraction. So the common denominator would be x plus 1, and we'll multiply that whole number by x plus 1 over itself, and then we will distribute the negative 1. So negative 1 times x gives us negative x, negative 1 times 1 gives us negative 1. The denominator stays the same. We'll combine the like terms in the top. 2x minus x gives us 1x, and the bottom is still the same. So now we're going to find the critical numbers, or the solutions of the top and of the bottom. So the top critical number would be x minus 1 equals 0. We find x equals 1. The bottom critical number is what we get for x plus 1 equals 0, so x is negative 1. On the number line, here they are, and we want to now choose a test number from each section, left, middle, and right. So for the left section, I'm going to choose negative 10. It doesn't have to be negative 10, just anything in this left section. For the middle number, I'm going to choose 0. That's the easiest thing to choose in between negative 1 and positive 1. And for the right number, I choose 10, although you could have chosen anything as long as it's to the right of 1. Okay, now plugging negative 10 into the top, negative 10 minus 1 gives us a negative result. Negative 10 plus 1 gives us a negative result. Negative over negative makes a positive answer, and we ask, is this positive answer less than or equal to 0? The answer is no. Okay, let's do the middle. If plug in 0 to the top, 0 minus 1 is negative. Plug in 0 to the bottom, 0 plus 1 is positive. Negative over positive is a negative answer. So is that less than or equal to 0? Yes. And then for the right end, 10 minus 1 is 9, that's positive. And 10 plus 1 is 11, that's also positive. Positive over positive gives us a positive result. Is that positive result less than or equal to 0? No. So the only part of the number line that we can shade is the middle part. And now let's look at our symbol and decide if we want brackets or parentheses. And we should want brackets because of the or equal to line. But remember, only the top can use a bracket. The bottom critical number has to use parentheses. So this time we got parentheses negative 1, comma, 1 bracket. And that is the correct answer for that one.